Hey everybody, today I'm going to talk about solving multi-step equations. This is actually going to be for a lesson later in the week, so you don't need to do this right now. So anyway, this is going to be for my algebra class. I want to talk about how you can solve multi-step equations. So I've got a couple here on my board, and the thought process with multi-step equations is going to be very, very similar to that of one-step equations. What you're going to look at is, can I find the variable? And then once I find the variable, you want to figure out what is happening to the variable. And there should be two operations that are happening to the variable. And then you just have to decide which ones you are going to undo and the order you're going to undo them. So in my red equation right there, you can see it says 4x minus 12 equals 28. Some of you could probably just figure that out in your head just because you're smart. You can just work it all out in your head. What I want to try to do is actually have a process, because you're not always going to be able to do it in your head. And so what I want to do is find the letter x. I can see I've got the letter x right here. What's happening to it? There are two operations happening to the letter x. Everybody can see that the letter x is being subtracted with 12. That doesn't take much brain power. But sometimes people can't see that there is multiplying going on right there with the 4 and the x. So now you've got to decide. I'm going to undo both of those operations. Which one should I undo first? My basic advice to everyone is undo the adding and subtracting first. It's almost like, if you remember PEMDAS from 5th grade, 6th grade, 7th grade, since we're kind of working backwards here to find the answer, it's almost like we're going to start at the end and then we're going to work our way like that. So I'm actually going to start with adding and subtracting, and then I'm going to end up with the multiplying and dividing part at the end. So I found the variable. I can see it right there. It's the letter x. How am I going to undo this? The letter x is being subtracted by 12. I can undo subtracting 12 with adding 12, right? And whatever you do on one side of the equal sign, you've got to do the same thing on the other side. And that should give you, over here, negative 12 and positive 12 cancel each other out. They equal 0. Those are inverse operations. So I just slash it out. You're still left with this, so I'm just going to drop it down. 4 times something, equal sign is still there. It's just hanging out. And then you've got 28 plus 12, which is obviously 40, if my brain can work a little bit of math there. And so now I know most of you know this in your head. 4 times what equals 40? If for some reason you were uncomfortable with that, you could say, okay, what's happening to the letter x now? It's being multiplied by 4. So the opposite, the inverse of multiplying by 4 is dividing by 4. And 40 divided by 4. Over here, 4 divided by 4 is 1. 1x is the same thing as just x. 40 divided by 4 is 10. And you have your answer right there. So you can see we took it in 2 steps. Step 1, undo the adding or subtracting. Step 2, undo the multiplying or dividing. Now, is that the only way you could do it? No, but that's probably the preferred method. Let me show you a couple other ones. Over here in green, same idea. I've got my letter N. There are 2 operations happening to the letter N. Everyone can see that we have addition going on. That doesn't take very much. We also have multiplying right here. This is negative 2 times N. So we have multiplying and we have addition. I would do the addition first. Just get that out of the way. How can I undo adding 15? The inverse of adding 15 is subtracting 15. And so I'm going to do that on both sides. Over here, 41 minus 15. Oh my goodness. Carry 3, 6, 26. Equal sign, just drop it down. I do the arrow sometimes. If you don't like the arrow, you don't have to do it. Over here, positive 15 and negative 15, those are inverses. Those are opposites. They equal 0. So I can cross that out, and I'm left with this part that I was saving for the end. Negative 2 times something equals 26. Okay, if you know that in your head, awesome. If you don't, the opposite, the inverse of multiplying by negative 2 is dividing by negative 2. And you get negative 2 divided by negative 2, which is 1. 1n is the same thing as n. That's what I was attempting to do. I want to have the letter n isolated all by itself over here on this side. 26 divided by negative 2 should be negative 13 for my answer. Okay, now, those are pretty simple. Those are the easier ones. Let me scroll down here and see if I can get you one that's a little more complicated. Right? What about if it doesn't have multiplying? What if it has something like, I don't know, right? Something like this. Okay, now I'm a little bit, oh, sorry about the bell. I'm a little bit confused here. It looks a little different, but is it the same idea? Sure. Are there still two things happening to the letter x, the variable in this question? Of course there are. I can see that it has subtracting, but now I can also see a fraction. And a fraction is also another way of representing division. So we have subtraction and we have division, right? And we need to undo both of those. And so my suggestion from earlier is still going to hold true. Whenever it's possible, always, always, always do the adding and subtracting part, undo that part first. And so I can undo this. I can do inverse operations with subtracting 3. The inverse of subtracting 3 is adding 3. And there you go, 7 plus 3. I've got it. That's 10. Over here, negative 3 and positive 3, they equal 0. We can cross them out. And so you're left with this, which looks a little weird, but don't let it bother you. Think about what that's representing. That says some number divided by 4 equals 10. If you don't know it in your head, which most of you do, if you just maybe don't realize it, the opposite, the inverse of dividing by 4 is multiplying by 4. And you can even do 4 over 1 if you want to keep it as a fraction. Whatever you do on one side, you do the same thing on the other. 10 times 4 is going to be your answer. Over here, 4 and 4. 4 divided by 4 equals 1, so that they kind of cancel each other out. And you get x equals 40. Right? Now, if you're not confident in that, you want to go back and check your answer, you can always take 40 and drop it right here into the original problem and ask yourself, okay, if I put 40 right there, and then I just copy everything else down, right? There's the original problem. That's this, right? I just moved it over here and I put 40 in the spot of the x. If I work this out, would I get the right answer? 40 divided by 4 is 10. Does 10 minus 3 equal 7? Yeah, of course it does, right? So I know I got it right. I don't have to guess. I don't have to look it up. I don't have to ask a friend. I know I got it right. Okay, let me move to a couple others, because those, if I'm being straight up with you, those are kind of the easy ones. What happens when they do this? Because this will every once in a while show up as well. Something like this. Oh boy. Now this one's a little bit more complicated, right? Big time issues here. My whole process of what I did on these other ones, where I said undo the adding and subtracting part first, right? You see, remember how like here we did subtracting or adding first, right? Even down on this one that looked a little weird, we did it right here. Step 1 was always to add or subtract. How in the world are you going to subtract something on this one? You really can't. Like, how can I even write? I can't even write subtracting 3 over here. And it doesn't work. And so whenever the entire left side or the right side, the side that has the variable, when that entire thing is one giant fraction, this is like the only time when I would flip my order. Instead of doing adding and subtracting first, on these, I want to do multiplying and dividing first. And this is about the only time it happens. It hardly ever shows up, but this would be like the 5% of the time whenever it happens. So whenever you're stuck with like an entire fraction over here, go ahead and do the multiplying and dividing part first. So I want to get rid of this. This is a major problem, right? Dividing by 4. I can undo dividing by 4 with multiplying by 4. And if you even want to do 4 over 1, you can. Whatever you do on one side, you better do the same thing over here. So I have 4 divided by 4, that equals 1. So anything times 1 just is itself. X plus 3 is the only thing left. And then on this side, 8 times 4, 32. And now look how easy this is. No one is going to mess up the question from here. The first step was kind of weird looking, but this is the easiest. I mean, this is like a, what, 4th grade question maybe? I don't even know. Instead of adding 3, I can subtract 3, but to be honest, you already knew the answer in your head. 32 minus 3 is 29. So that's the only time when I feel like it would maybe be appropriate to do the multiplying and dividing first, because all the rest of the time, I want to do the adding and subtracting first. So remember what that looked like. When the entire thing over here, when the entire left side, or it could be the entire right-hand side, the side that has a variable on it, when the whole thing is just one giant fraction, that's when I decide, okay, I'm going to flip my order here. I want to do the multiplying and dividing first instead of the adding and subtracting part first. Okay, we're hanging in there. There's one other type I want to show you, And that is going to be here in a second. Give me one moment. I'm going to go ahead and grab this out of my book just to make sure I don't mess it up. Okay, I remember what it is now. So every once in a while, our book people will be a little more complicated. Oh, geez, I don't know. I'm just going to do this. Whoa, what happens when I have more than one x? Now I have to think about this, right? So before I think about doing things on both sides of the equal sign, like I just got done doing all those questions where I said, hey, do adding and subtracting first, and then multiplying and dividing last. That's what you can do whenever you don't have any like terms to combine. I've got too many x's. How can I solve it for x when I have multiple x's up there, right? And so before I even think about undoing anything and doing any inverse operations, I want to do combining like terms, right? Can I simplify something over here on this left-hand side, right? I've got way too much stuff over here. I'm not used to seeing this. This doesn't look anything like the questions we just did. The problem is I have too many x's, right? So I've got 3 x's here and 2 x's here. We can combine those together. You should have done this last year in 7th grade, right? 3 x's plus 2 x's. If I combine those together, 3x plus 2x is, right, 5 x's. And now I'm just going to copy the rest of it down. I know some people try to do the whole thing in their head. I don't recommend that, right? Just copy down the rest of the question. -5, equal sign, 10, just drop it down, right? So over here, if you're really trying to keep track, I combined like terms. Every once in a while, you'll see a question that says justify your step or justify your work. That's what it means. What did I do? I did combining like terms, right? And from here, now doesn't this question look just like the other ones that we did? Of course it does, right? This looks just like the 3 or 4 that I showed you right before this one. Now I can say, all right, I've only got one x. I've got an operation happening to the x. I've actually got something happening right here where it's multiplied. So now I can do the steps that I've been working on all day, right? First thing first, let's get rid of the subtracting. How can I undo subtracting? Instead of subtracting, I can do adding 5. Right? Whatever you do on one side of the equal sign, you do the same thing on the other. And over here, -5 and +5 equals 0. Those are inverses. They cancel each other out. Over here, I get 15. Just drop all the rest of the stuff down. 5 times something equals 15. And if you make it to this point, you're made in the shade, right? Instead of multiplying by 5, I want to divide by 5. But let's be honest, we all knew the answer in our head anyway. We really didn't have to write this out. But I could. If you wanted to keep showing your work, if your teacher is, or your question in your book or on the computer is being really strict and wants you to justify your step, like what did we do here on both sides? We did adding 5 on both sides. Or if you really want to be fancy, that's actually called the addition property of equality, if you wanted to say that and sound like a real smarty pants. And then right here, when we divided 5 on both sides, you could say the division, if you want to sound really cool, property of equality. The division property of equality. What does that mean? It just means if you divide by the same amount on both sides of an equal sign, you still have a correct answer. So there it is. This is simplified answer, done, 3. Okay. Let me show you one more of those because that was kind of an easy one. Let me see if I can do one a little bit harder, just in case our book decides to throw one that's really hard at you that you don't get super confused. I'm just going to make these up. 32. I hope this works. 3x plus 10. Oh, minus, no, let's do plus 8x. There we go. Well, yeah, okay. I should have probably put a minus in there, but whatever. Okay, same idea. It's just a little bit twisted, right? The x's are on the right-hand side instead of being on the left-hand side. Don't let that throw you off. It's still okay. The right-hand side, though, is where we're going to do all of our work on this one. The right-hand side of the equal sign is what I mean, if you don't get what I mean here. I've got way too many x's, right? I've got an x right here. I've got an x right here. And so I need to combine those together. Can I do 3x plus 8x? remember, it's not just 8. Look where I put my squiggles. I even collected the adding sign in front of it, right? If this would have been minus, we would be doing 3 minus 8, which would be negative 5. But that's not what we're doing. We're doing 3x plus 8x. We can do 3 plus 8. That's 11x's, isn't it? And now let me just go ahead and copy the rest of this down. Minus 10 or plus 10, just drop it down. Equal sign, just drop it down. Right? If you like drawing these arrows, go ahead. If you don't want to draw them, that is up to you as well. And I get 32 equals 11x plus 10. Right? All I did over here is I combined like terms. Donezo. Okay? Okay, now this looks like a normal question. I have 2 operations happening to my letter x. I have adding and I have multiplying. And now I can undo them. Let's undo the adding and subtracting part first. Instead of adding 10, I want to do subtracting 10. If you do it on one side of the equal sign, you better do it way over on the other side of the equal sign. Don't do it here and here. That's not on the opposite side of the equal sign, right? You've got to go on the other side. This is 22. This is just going to come straight down. We're not dealing with the multiplying part yet. Here, positive 10 and negative 10 equals 0. They cancel each other out. If you're ever doing this and you don't have something cancel out, that is a clue that you have done something wrong. So here I have 11 times something equals 22. Instead of multiplying by 11, I can divide, but let's be real. We all know the answer in our head. 22 divided by 11 is 2. Don't let that throw you off. Every year, 8th graders are like, wait, I've got x equals 2 and they have 2 equals x. Yeah, it's the same thing, right? Don't let that bother you. It's the same thing on both sides. Okay, I think that might be a good place for me to, sorry about that, for me to stop. There's some other stuff in this lesson, but I'm going to stop right here because I don't want to give you too much at once, and I'm already at about 17 minutes on my stream here. So I'm going to stop at this point. I'm going to upload this and put a link to this in the Google Classroom. So do whatever you need to do to check this out. And feel free to ask me questions. Make sure in the Google Classroom you look and see what the assignment is. And hopefully you can do some questions like this and not have any issues. But if this did not make any sense at all, or you didn't even catch a single bit of this and it's all just super confusing, don't be scared to ask me for help on the Google Classroom. So shoot me an email or post a comment on there and I'll be more than happy to help you. Thank you so much for watching this one. This was the first part of lesson 1.2 in our algebra book, solving multi-step equations, and I will see you in another video. Be good out there, guys.